Well, hi, good morning, and welcome to my shop here on another cold, yucky, gray, rainy day. Good day to be in the shop. And what's going to happen here today is when I replace the power supply, the larger capacitors in here, I had to replace two smaller ones. They were just simply in the way. So I got two capacitors to test. This will give us some idea of the condition of the capacitors in the radio otherwise. And I think it might be a smart idea to test the tubes in this radio. And in thinking about how it didn't work yesterday, yet when I touched the grid on what is, I guess, a second tube in the radio, I think it's the second tube, out came the sound. So conceivably everything's working past that. Left me wondering about that battery. And if the battery that's inside the chassis here is actually stopping the signal from getting through the radio. Don't know. That's a curious sort of thing to wonder about. Now, what did I just say was number one on the list here? Testing these capacitors. Well, come on over here. Let's have a look-see. Pretty good condition for an old capacitor, but this is the only way to know. So I'm going to put a DC voltage on this capacitor. A really good capacitor will leak virtually no current through it. This one's bound to leak some current. The more current that leaks, the more this eye stays closed. That's the best way to put it. 50 volts going on the capacitor, and it doesn't open at all. The eye's not opening at all. So that's actually a very bad. That's bad. You're bad. Looks good? No, it's bad. It's bad. So this one's bound to be the same, but let's see. And this will tell me what the condition is of all the capacitors in there, which cannot be surprising if it's bad. Here we go. So this is an odd result. This is a very odd result. So what happened here was hit the switch, the inrush current caused the eye to close briefly, or come close to closing. It then popped open very quickly, fraction of a second. Then normally what happens is the eye sits wherever it's open to, or it may continue to open slowly a little more as the amount of current, the charge fills up and the amount of current drops. This one, the first time I've seen a capacitor hit it with the charge, and the eye, instead of opening back to something, began to slowly close after its initial rush. We'll watch again here. Well, if there's any movement in it, it's very slow, but it's actually slowly closing. It's like the capacitor's getting worse as we sit here. Bad. I mean, you can only qualify this as bad, 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 bad. So that's encouraging for the replacement of the rest of the capacitors, which didn't really require much encouragement. But it's worth doing that. Once in a while you get a surprising result. Once in a while I get a radio in here and the capacitors are still in really good shape. So the next thing is tubes and a bit of a cleanup, because this is a filthy, dirty radio. Dust everywhere on it. Some kind of thin, like powder, like somebody did some sanding somewhere near here. And then yeah, well, let me clean this up before we do anything more. Okay, first tube for testing is a 6SA7. Got my tester already set up for the tube. Let's just get a little more lighting here. There. Okay, we'll double check. 6SA7. 6.3 on the filament, 2 for the signal level, 9 low for the bias, 27345, 27345. 1650, 1650, 45 C. Should read 1100. 1100 is the reject point. So 1100 is going to be just above where my finger is now. Let's see how we do here. Shorts, watching the meter. No shorts, ready for the test. 1100, just above my finger here. Oh, she's a beauty. Okay. SA7. So this is a single test on this tester for this tube. So that's not going to be a problem. That particular tube. The next one is in this cover or shield. It's quite the shield, eh? You see there's a locking band around it here. She comes 6B8 6B8. That's got to be the right tube. 6B8. Probably. Well, this could be the original tube. Too. It says GOAT. G-O-A-T. GOAT. New York. Patent pending. I wonder if they ever got their patent. Okay, now we got to set up the tube tester for a 6B8. 6B8. Now, I've heard from many of you that you really enjoy watching tube testing, so 6B8. Lighting's a little poor here. 6B. Poor for me. 6B8. There it is. 6B4 and 6B8. Okay, 6.3. Signal level. 6B8. Right, signal level 2. There's 2 tests for this tube. 30L. 27300. 27300. Just following the right line here. 4610. It's really easy to make a mistake. Oh. 45 and C. 45 and C. Grid cap. This is the grid cap here. Okay, we can pop the tube in. No shorts. I don't see the heater in here. GM test for this tube. We should get above 860, so above where my finger is now. It's right there. Okay, and then we do a second test here on the diode. Signal level doesn't matter, bias doesn't matter. We have to change these numbers, these settings here. 2703P. 2703P. And then 0610 0610 46. Oh yeah, my one little number added there, and 8. P1 and P2. So these are four. Oh, I thought that was going to fall. Holy smokes. Yeah. This is for the two diodes that are in this tube. Let it warm up again. So in the other chassis, there's a metallized tube in this position as opposed to this glass one. Check for shorts again, just in case. Now this time we're throwing the rectifiers and diode switch P1, P2. So diode only has to get above where my finger is now. And it's perfectly above it. And then we're switching to P2. It's a little low. But I don't think that would make the radio silent. Like the radio itself seemed to pass no antenna signal through it. I think this guy's good enough for now. It's definitely functioning. Especially the amplifier portion of this tube. Yeah, might as well put this back on. If you don't put this on and you operate the radio, there's a good chance that the tube will pick up signals from the radio itself, and you'll end up with feedback and some kind of oscillation going on. So even while doing the testing, it's important to have this shield on there. Now the shield is supposed to be clamped by these clips, but you know what? There's really no springiness left in it. Bring it in a bit. Okay, so the key is there. Key is there. There we go. Down there. Yeah, it's in contact. Okay. Next one. Next one. I think this one is the rectifier, I think. 6x5. 6x5. Is that what was in here? Yep. 6x5. Okay. Not too likely this tube is bad, because the radio really wouldn't have made any sounds out the speaker. Hum or anything really. 6x5. X. Right there. Okay, 6.3 doesn't matter about, it's a rectifier. 2730P. 730P. 0610 0610 25. And the cheater control. E. P1 and P2. 6x5. E. A rectifier tube, so we're pushing the rectifier and diodes, but this time it has to come all the way up to here where it says rectifiers. No problem. Plate number 2. No surprise, tube is fine. Okay. So this will be the output tube. 6K6. Again, it's not likely this tube is bad, or I think we would not have heard a thing. But it could be weak. Generally in radios, as they play on, as they get more and more mileage on them, it's the output tube and the rectifier tubes that tend to wear out regularly. Of course, nothing's regular anymore for these radios. What's regular is sitting on a shelf. Okay, 6K6. 6K6. G, J, 6K6 right there. Signal level 2. 46H. 07345. 07345. 0610. 0610. 44. F. 1360 is the objective, up about here. 1360 is the target. So there's a family of tubes, 6K6, 6V6, 6W6. Some interchangeability between them, 6F6. All getting a little scarce these days. There we go. No shorts being reported. Transconductance. $13.60. $13.60. Good. Good tube. Good show. So what did we just find out so far? We've done the 4 tubes in here, and they're all good. So that's not the reason this radio didn't produce anything. Didn't produce any radio signals from the antenna. I've cleaned it up. Maybe cleaning it up has helped it. Let's give it a try. Okay, my little radio. Power on. Switches up. There we go. Tubes are lighting up. Nice clean tubes. So what I noticed last time is if I inject a signal into this grid, it comes out the speaker, just getting close. Kind of gives you an idea why this tube has to be shielded, doesn't it? So I believe what's happening there is my hand and me, I'm an antenna, I'm isolated from ground. We'll do a little experiment in a moment. Do it right now. I'm taking my slipper off, hands out. I'm going to short myself to the ground here. Hold my hand closed. No. I was going to see if I could ground out the signal that's in me. So I believe I'm an antenna bringing up a signal. But if I touch the chassis, the signal in me is nullified. Okay. Hey, I like being an antenna. What can I say to you? So, talking about an antenna. So this is the antenna. This bundle. Hey, it's the same wire as this one. But we need something a little more hefty on there. So this leads to an outdoor antenna, but I think the switch is off right now. Oh, hear that? Something coming through the radio, but that could be coming through in all kinds of weird ways. So there we are. Antenna connected here. Just really nothing coming out of the speaker. Hey. No, it's still there, but now I got it up full. It's gotten quieter and quieter. So that suggests a couple things. One is a leaky capacitor leaking onto the grid of the output tube. That's a bad thing. We don't want that happening. As it leaks, it pushes the grid bias, and eventually the tube's response disappears. This is full. So we want to get through this further. Yeah, I'm not going to tune much with this anymore, am I? There we are. Nada. Not a thing. You hear the scratchy sounds. Okay, I think the only smart thing to do from here is to continue with capacitor replacement. Really go after the grid. Actually, you know, we can measure the grid on here. Maybe that'd be fun to do. You get ideas about what might be wrong with something, and you make changes to it, and then the problem goes away, and then you're convinced your changes fixed it. But maybe you're completely wrong because you never assessed it properly in the first place. Or the worst case, what was I told in college? The worst thing you can do when you're answering a question, and this is around electronics and mathematics, is end up with a result that's close because you can't recognize the error in it. So you calculate away and that looks okay, but in fact you're wrong. So you never want to be almost right. You either want to be right or really terribly wrong. That's the two ways to go through life. So now don't forget, the radio is silent. I turned it off. Don't have to worry. Concentrate. Focus back on what I'm doing. am I doing now? I want to look for, I'm going to check for the B plus, what it really is. I usually use an indicating meter for this, but we'll use this one. $45 and on the other, what? You know what it is? It's the radio's not turned on. That's a good explanation for that. Let's see what we get now. There we go. Right off scale. 200, that's roughly what's supposed to be in this radio. And the other one might be bigger. I didn't stabilize these connections. Shame on me. 230. So I think that's perfectly fine. Now, what do we get out here for B plus? Let's us look. We'll just guess away. We'll just go one to another. Something there already. What was that? 79. These are all grounded. 79. Oh, something coming through. There's the plate. So if I tap the plate, you can hear it. So what's going on here? We've got plate voltage there. I got something here. And then we got something there. That's not really right, is it? You're supposed to have 3 pins with high voltage on it. 4 pins. This resistor is a 2-0 with an orange, so that's 20K here. And on this side of it I read 76, and on this side of it I read 79. I don't know if that, does that make sense? 4 pins with high voltage on it. Let me write these down. And we'll look at the schematic and just see if this makes any kind of sense. So, the first one was here's the shame, man. Get yourself a shock doing that. So here's the key. That's 1. So 2, 3. 3 had a big whopper voltage on it. 3. 214 on 3. And maybe this is all correct. And it was 4, which had the no, wait a minute. 4 has 135 volts on it, and 4. So that would sound like plate and screen. And then these two down here. Guess that these are 2 diodes, and that's pin number 1, 2, 3, 4, 5, and 6. $75 volts. But it just doesn't, something just doesn't seem quite right there. Okay, power off. Let's look upon the schematic and see if we can analyze this initial situation here. take a little, we'll bite off a little chunk of the schematic. Okay, let's see what we can figure out from here. Here's the 6SA7. Well, it's got some voltages here. 175 on pin 3. I measured 214 on that. Pin 4 should be 85 volts, and I measured 135 volts. Wow, that's kind of interesting. These are way high. They're coming from down here, because this is all way high. You know why? Because I'm looking at the radio that used a field coil. And I don't know what these numbers are really supposed to be. Huh. Because maybe they're a lot higher in this radio. So you have a 1200 ohm coil here on the schematic, but in my radio this is a resistor, 2200 ohms. You know, offhand you would say, well, that 2200 will just drop more voltage. You expect this to be lower, not higher. Well, you know what? I don't know. I don't know exactly what they're up to here, or how or what. I don't know how or what. This number's about correct. So this number is just about right. Wasn't it a touch low? So I'm getting pretty much the full shot all the way through. You know, without having any positive information, I can't really identify what these voltages should be. That's what I want to say. They're kind of a doubling of each one of these. Not really. No, not really. This one's a little higher. This one's much higher. And then there's two more voltages I'm getting. I'm getting voltages on pins 5 and 6. So 5. 5 is the oscillator grid, if you like. It's the grid that is used for the oscillations coming out of here. How do you get, let's look at it. So if there's DC on it, it's got to have come through here. Oh my gosh, where would it come from? Leaking back this way. This capacitor is shorted, and the current's, oh, here's that crazy volume control arrangement right on the antenna. Right. That means the DC, if it were getting here through a leak, it's at a long road. Look at R11. R11 is some big thing. 50 ohms. No, it's not. Small guy. R1's a million, I think. It doesn't say. Why wouldn't you tell me what it is? Keeping it secret. It's written somewhere else. Well, this is going to be a fairly large resistance here. I don't think, so once again, so it's on both pins 5 and 6. So, oh, 6. So 5 and 6 are joined, kind of. 6 is the cathode, so they're running the cathode current through here, and then transforming it over to here, and then sticking it back on a grid, and that's what gets the oscillations going. Where do you get this voltage from? The voltage in the radio has to come from this line here. So into that tube there's this path to the plate, and in that case I get 214 volts here. We jump over this resistor and then it's straight up to pin 4. Pin 4 I get 135 volts. So this resistor is dropping the difference. That explains those two. That's easy. Now these guys, they have a voltage on the cathode of 76 volts. This just doesn't sound at all right. How can you get it? So you cannot get it this way, and there's nothing over here to get it from. It has to come this way. If you can get the voltage here, maybe through here, it shows up here. There's no current flowing, so even if R2 is a fairly big thing, 22,000, it's not really big, no voltage drop. So what you see here is what you see here. So how do you get it here? the only, oh my gosh, how do you get it there? So this is the this will be used for AVC purposes. This is the AVC output of this backwards facing transformer. This is the primary, this is the secondary, as I understand it. So all that's on here is an AVC voltage. That's no 76 volts. I made a measurement error. There really isn't 76 volts there. Moving the volume control will move this in the, I assume is a loud setting. You put a ground on here. Basically grounded all this through this 50 ohm. I don't see where the voltage gets into the rate, gets into the tube. I need something to go on here. I'm going to go on the idea that I didn't test it right. I'm going to redo that test. I really can't imagine how I managed to not test this right. I'm going to use the indicating meter just because I like it. I like the swinging pointer. That's this meter over here. Digital meters make you think too hard. Okay, I'm going to put the power on. We're on the 150 volt scale here. That'll put the meter right over. Yeah. 500 volt scale. And we're measuring 220. 220 here, and then this one 240, a little higher on this one. 240. $220. Means a little bit of voltage dropping on this guy. How hot is it? Cool as can be. Cool as a cucumber. No heat in this. Okay, going back to the tube now and checking the tube voltages. Pin 1 is grounded. Pin 2, my zero's a little off here. Pin 2. Pin 3, 210. Pin 4, 130. Same voltages. pin 5, 150 volts now. Pin 5, 75 volts. Pin 6, 75 volts. That's the resistor in between. 20K. What did I say it showed on the schematic? Just let me peek here on my own for a moment. So that resistor is between pins. So that's R2, 22,000 ohm resistor. 22,000 ohm resistor, but this is 20,000. 20,022. Guy reached in the wrong bucket when he put that resistor in. 1/10 watt. You know, I just don't think there should be really anything there. You know what we need to do right away is check the grid on the output tube. Let's just do that right away. If it's gone way high, we have to deal with it. Can't let, because it's cooking the tube. Otherwise, 6K6, isn't that what it was? 6K6. Oh, I can just look on the schematic here for crying out loud. 6K6, the grid. Pin 5. Pin 5 with a pin 5 on the output tube. So the output tube is right here. Oh, cheapers creepers. How am I gonna see into this mess? Pin 5. Well, the key is blocked. I can't see the key. Sometimes you can see the key slot. Looking down. Sometimes you need enough light to see with. Let me get a little more light here. Do not see the key, so it's either right below here or right below there. There it is. I see it. It's right here. So that's 1. That's pin 1. Now, what am I looking for again? I'm looking for the grid pin 5. Pin 5. So we go 1, 2, 3, 4. This is 5 with a million ohms on it. This is it. So the meter should go backwards. Not going anywhere. That was on such a high setting. Meter should go backwards. Pin 5. Which one was pin 5? This one. It's not going anywhere. Whoops, 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 whoops. Oh, you can't quite see the meter. An exciting moment there. I whacked that. I guess I hit the high voltage. Look, it didn't bend my needle. Well, why is there none? Okay, there is a little bit of movement. Okay, I'm on the 1.5 volt scale. Negative now, so it should go upscale. All things being good. It's going downscale. Showing there's a slightly negative voltage on there. Now the capacitor that's protecting that, I think, is this big thing here. So on the other side of this capacitor should be B+. Or something like it. It should be on the other side of that capacitor. I'm looking quickly. Very quickly, 200 volts, something like that. The lead, which can hardly be seen, is going to this spot here. Back that way. 200 volts, right on the money. So we have 200 volts on one side of this capacitor, and on the other side, I'm not going to see it like that. We have a slightly positive voltage. I think this guy's got to be changed out. It's not the source of the problem that we're having. Grid, what's the proper grid bias? Maybe I'm not doing this right. If they may have biased this in a couple different ways. Quick, look at, I got it right here. No, this is a cathode bias. 12.5 volts, got it written right on it. I may have done this wrong. I should be looking for the cathode voltage on pin 8. I should be looking that way. Didn't do the test right. Cathode voltage on pin 8. So 5. Well, 8 is going to be right up in here. So 12 volts cathode voltage, and it should read upscale on positive for this test. Cathode. I kind of lost track of what I was doing. Cathode pin 8. Okay, the meter's going up. It's kind of going up to 15. Okay, no problem. There's no problem there. No problem. I was testing it wrong the first time. Good. So I don't have to worry about the output tube. The output tube tested good in the tube tester. If it was beat up by a bad blocking capacitor, then it wouldn't test so good, I would think. Now what? Now we're left wondering, well, why aren't we hearing anything from this radio? Maybe we need to listen to it, listen to the signal going through the radio. So we could listen right on the first tube up here. And we can listen using this guy right here. We'll try it. So kind of in the early stages of fixing up a radio like this, I realize that there are unknown unknowns in there. to quote somebody. Now, this guy has his own hum, so ground. Just because I'm chicken, I always do that. So what we're listening for is a radio signal in the AM band. So I'm going to turn this into a radio receiver here by picking that. What happened here? Something in there making that kind of noise? There's something in my shop making this radio noise. How much you want to bet it's this? Cut the power. Okay, I lost that bet. What is making this sound in here? Oh my gosh. Band B. Okay, so we were listening more or less for a local oscillator type frequency. Now we're listening to the AM radio. Oh, there's that noise. It's still there. See, I'm acting as the antenna here. Under the right conditions, you pick up signals, and you can listen to them on this radio. So what we want to do is we want to see what is reaching the grid of this first tube. Take my finger off it there. Grid of the first tube is pin number 3. No, I want the third grid actually. Grid number 3 is pin number 8. So we want to listen to what is on pin number 8 of this tube. Okay, bearing in mind this radio is tuned where? Tuned about the middle of the band. So I have to tune this one roughly the same. Okay, now. And it's been enough time, I've forgotten the pin number 8. 8. So, where's the key? Here's the key right here. That's pin 8. Pin 8, hand on the volume controls. Just get that out of there. Pin 8. See what it sounds like. Okay, oh, arm in the way. Not sure what that's told me. Well, I'm going to tune this radio, which is difficult now because the string is broken, and see if the sound you hear changes. Oh my gosh! Oh yeah, that changed. That sure changed a lot. Okay, we're going to do this. We are going to use a clip lead here, so I'm a little more comfortable with all this, even though putting wires on here is making more and more of an antenna in itself. We're going to clip this on here. Turn this down. Is that the right one? Yes. What a pretty weak clip. Okay, that's good. Now, I want to tune it again, only I want to do it a little less clumsily. I think I gotta change up things here. Okay, volume down. This lead off. The ground's off. I'm gonna lay the radio down. Yikes! Let's see. Wow. Okay, so what happened there? What happened there? I didn't see it. What could have happened there? So the antenna was flopping around, but you shouldn't get a big snap off of this thing. Did it fix it? Didn't fix it. Okay, now I want to reconnect the equipment. I'm going to turn the power off here because I'm freaking out. Once you've gotten enough shocks, you become, I guess it's shock shy. Where's the other ground? Lead. And on this we want to put this back on pin 8, the output tube. Pin 8. Not the output tube. That's the problem. Pin 8 is right here. You know what the snap was? It might have been this. Because I didn't stabilize these properly. That's what it was. Okay, I gotta do something temporary here. Where I used to work in the power company, we had something called temporary permanent. Our trouble crews would go out at night and do some temporary repair to restore somebody's power, and then the next day the proper crews are supposed to come in and make a proper permanent repair. But of course what happens is the next day there's too much to do. They can't get back to the trouble job from the night before and the night before and the night before, and before you know it, temporary becomes permanent. You can probably see these in your neighborhood. you have underground street lighting. They build your neighborhood, they put in underground street lighting, fantastic. But then later, when there's trouble on the street lights, the utility is not interested in spending $50,000 to fix one street light by digging up the defective wires and replacing them. Instead, trouble crews come out at night. They want to, oh, this isn't going to work. They want to restore the street light. Street lights are a safety issue. So what do? They run a wire between poles. They go down to the next pole where the street light's working. They tap off and they hang a wire between the two street lights. They just abandon the underground. The idea is, you know, the day crews will deal with that. But the day crews are too busy. And that kind of thing is such low priority. I think you can go into any city that has underground street lighting, and as you drive around the streets, you'll see these wires running between poles here and there, often in a very temporary and poorly done fashion. And they become permanent, and that's temporary permanent in a power company. And if you work in a power company, you already know this, because it's probably happening where you work. And there's probably all kinds of other environments where temporary things become permanent. So we actually called it temporary permanent. What's the name of it? We called it that without laughing. That's how common this was. Okay, I'm ready. The objective is listening to the front end of the radio with this radio while tuning this one should give me some idea of what's going on. The thing is, this is a tuned radio too, so I have to tune this one in conjunction with this guy. So I'm going to move the capacitor open right now. Incidentally, you can touch the rotating part of the capacitor in most radios, maybe all of them in fact, because the rotating part is actually at chassis potential. This capacitor is the bearings are so loose and it's actually falling down. Good. Leave it like that. Connections made. Ready to go. Dim bulbs. We're on. We're cooking already. Things are warming up. This radio just gets quieter and quieter. So my finger just brushed this can and you heard a little click, and I believe that was a static discharge coming out of me. So I'm going to charge up, click, charge up, click, very, very faint click. None of this is helping me fix this radio though. Okay, so I have the capacitor open. I always forget which end of the band that is, but we should be able to tell. This thing should hear a peak, I think. Seems to be up this end of the band. Okay, now I'm going to try to tune this a little bit. I just touch it, it's just dropping. Well, it's tuning. I mean, it's going one way. Oh. So now that sounded like a capacitor short. That sound. Let's see if I can just grab onto this. Oh, that's radio sounds. Shorts in this capacitor. Oh, I think I just left it at an unshorted spot. So this is showing a big signal right at the end of the band here. Look a little closer at this. See, it's just marked out with the frequencies of the AM radio band. This is 1600 up here. But the radio itself is tuned around here. And I know that because you can see the capacitor is half open. I don't know, what does it mean? I don't know. Another thing is, when I'm doing these tests, I make observations. I just kind of register them on the shelf in my head, and I don't think too hard about them sometimes because I'm not sure I haven't gone down the wrong river or something like that. So I just make the observation and carry on. You're watching me do this, you might be wondering, well, what use is that? And the answer might be, I don't know yet. Somewhere down the road, what I've discovered now is going to suddenly make sense. And what did I discover? I haven't discovered anything. I don't think. Except I managed to... Well, it's still got something going on here. Wow, it was a lot louder before. That could be because of this connection. That shouldn't be the case. No, that shouldn't be the case. Okay, so getting back to what I'm trying to do here. I will once again try tuning this thing. Oh, I already discovered there's a short. You can just hear it. You can just hear it dragging on. And you know what else? The capacitor kind of fell. So it fell to a point, and now it won't fall any farther. Why? Because I think the plates are jamming. Okay, so we got to investigate the plates at this point because a shorted capacitor is going to kill this radio forever. So we're going to see what we can find out about this situation. Power's off. I'm going to pull the plug out here so there's no mistake. That's a terrible sound. Views blocked a little bit. This is soldered right in here. Okay, now again, a string is broken, so I have to do this by finger. Wow. If you ask me at this point, I'd say there's no shorts in this. So I'm looking at each individual plate for it being not centered or just looking like it must be in contact. I don't see a thing. It's also very loose here. You can hear it. Or is that the string? The remnants of the string. Oh my god, that's right. That's just, you know, way back. I don't see any hint that there's a rubby one. There's one there that looks a little tight. There's my stick. Wow, I just realized replacing this string. There's nothing easy about this. Now, there's a piece of string hanging here, and I think that's what I've been hearing. A piece of string. Okay, can't hear him now. Sure enough. So what did I think was happening with this? It sure seemed convincing when I was testing the radio. feel, I don't see any shorts. What's happening? Okay, let's fire it back up here. No equipment connected. Clip leads connected here. Take it off. Okay, nothing connected. Antenna wire hanging down the front. Full blast. Okay. Tuning the radio. Volume's up full. Oh, a little scratchy sound there. How do you get this back up? Yeah, I don't think there's a short here. Can you see this band right here? So that band is actually a spring. There's one on the other side exactly like it, pushing the other way. And it's pushing back right against this edge of this. And this is how they're trying to ground this rotating piece using these spring clips. There's another one back here. Sometimes they got them in the end, but almost always they're right in the middle here. These guys, if they aren't making good contact, as you rotate it, you hear sound, and just maybe, I just blast a little bit of my favorite fix everything stuff, WD-40. Look at how loose this is. Okay, got rid of that tiny little scratch. Not helping this radio any. So we could put a signal in here, see what comes out the speaker. Take a different approach. Right now I've been doing the signal tracing, but there's no signal to trace. Could pump in a high level signal, see if that comes out. Could pump in a IF signal, see if that comes out. Could pump that right in. Let's see. So this is a strange radio. IF transformer. Output through here. Output of this tube through this transformer. This one's generating the AVC voltage. It's just a weird arrangement in here. Just fishing around here in all kinds of ways. Yes, and there's more capacitors in there to change, and yes, the two I did take out showed up pretty bad, so probably there's a killer in there. And really that's what I need to do, is just keep changing the capacitors. But that's not as much fun as doing this. So first we'll try jamming in a powerful AM signal. See if anything comes out. Okay, and clip this onto the antenna. what, this big bundle of half bare wire is actually a bit of a danger, so I'm going to cut it. Get rid of the excess. Okay, signal in. Should be feeding, that's a weak signal. Strong, whoa, whoa, whoa. Bare wire going places there. Oh, we won't. This is turned up full. We're at about 950 on the AM band. So I'm just going to sweep this up and down, see if anything comes out, and keep jacking up the power level until we get something. And this, I believe, is tuned around here. We're going to go through the IF frequency too. Shh, everybody quiet. I didn't hear a thing. This is a modulated signal. Nothing. Okay, now that was kind of a standard level signal, if you like. Now let's give it blast the front end. Any radio can pick this up. Right down into the IF frequency here. Nothing. Nothing at all. I'm sure I got this connected right. Yep. Yep. Okay, so maybe I just didn't go high enough. Maybe I'm wrong. We're at 990. Let me swing the capacitor up and down here. If I hit the mark, it's going to come screaming out of the speaker. It's nothing. Boy, this is a dead radio. So we know that a signal that gets this far comes out the speaker. The signal here, what should it be? This should be should be 455. And this is audio, I think. I'm not sure. Look at the schematic just for a moment here. Right. So the 6B tube, this one, is the detector tube 2. So the grid cap has the output of the IF on it. Everything is on there. So even the IF frequency should appear on there. Oh, this is a really strange arrangement. Yeah, really. Yeah, the IF should be there, IF frequency. So let's see if we can find it. There. You need some kind of signal coming through. Oh, I think I'm beating a dead horse here. IF frequency. Loads of power. Oh, finally! I was going to say you don't even need a radio for this one. Ooh. 300, is that the, what? Oh, the radio's working. Is the IF frequency is what? 300 something? IF is 455. It says right on the schematic. Well, why is this thing so sensitive at this? Don't know what I'm doing, but it's interesting. When I pump this into the antenna, it doesn't make it. Let's try pumping again. The capacitor is superfluous because there's a capacitor in this box here already. Okay, just in case you're pondering what I'm doing. The apparent irrationality of it all. Okay, I'm sending in a whopper of a signal right now. I can't make it through at all. Okay. Kill it. Kill that radio. Can't kill something that's already dead. It could just be flogging a dead horse here. There could be an open capacitor or a shorted capacitor, and no matter what I do, it's not going to make a lot of sense until I deal with that. It's really not likely to be the case, but... So I've only got 1, 2, 3, 4 more to do, really. These are front end. These are tied in the IF somehow, I think. And then that crazy volume control on this radio. So the volume control is right on the antenna. Is this radio the same? That's the other one. It must be. Yeah, I can see a green wire running from the volume control heading right up towards this antenna coil. Volume control right on the antenna. I really thought they'd done away with that in the late 1920s. Okay, I know what I gotta do next. Okay, 4 paper capacitors out. Let's give them a quick test. Quick test. Only 50 volts. Shot. Lots of old capacitors don't close this eye on 50 volts. It takes 150 to do it. These ones aren't particularly bad. I have my hand in front of it there. They're all shot badly. Badly shot. So I think it means this radio spent some time in a humid type environment. Now that one opened up a little bit. But it's a bit of a qualitative test. And the quality is, that one's opening up just a little bit too, a little bit a smaller capacitor. But that's no good. It should look like that. I should hit the switch and it should pop open like that and go all the way up to 250, 350 volts before I would say capacitors are good enough to be left. There we go. Now let's see what happened to the radio. All all these nice new parts in it. Okay, that's good. What do we think is going to happen this time? Who knows? But for sure we want to pay attention to the dim bulbs here because I did capacitor work. And believe it or not, I make mistakes. Believe it or not. Ready? Okay, tube's warming up. Dim bulb showing nothing. How about your little radio now? Probably wouldn't hurt to put a light bulb in here. She's mighty quiet. 114 volt supply because I still have a dim bulb in the circuit. Well, it looks like changing those capacitors made a hill of beans worth of difference. Of course, I don't have the antenna hooked up to anything. Yeah, that's right. Hook it up to me. Volume's full. Apparently I'm not really a very good antenna. I don't think the switch is thrown properly for this antenna, but there's just nothing coming out of this radio. Oh yeah, don't do that. That's not good. Did I do that before? Nothing. Nothing. Nothing from the radio. I saw some suggestion here doing earlier testing that the IF frequency is so far off it's hard to believe it could possibly be that far off. Let's pound it with a signal tracer again. Did I say signal tracer? Signal generator. Okay, volume is up. Boy, you'd never know it. There's a slight hum there, I can feel it. My finger is doing something. Okay, little radio. Let's go up. Let's go up. Little camera. Come on, radio. Let me tune this roughly in the middle here. Okay. A very powerful signal now. You shouldn't even have to turn the radio on to pick this up. It's so strong. There's just nothing coming out of this radio. Nothing at all. Nothing at all, even with a signal so strong. Wow. Well, that's as far as we're going to get today. It's not all that far. And what's happening here is I'm investing in a radio that's not working yet. I don't know why. There's a risk. I'm going to invest time and effort, a few parts here and there, and it's never going to work. I don't like that. I like these things to start working even if they barely work. Start working as soon as possible. Anyway, that's it for today. Thanks a lot for watching.